How difficult do you think it is to measure the temperature of a golf ball? Our next demonstration will answer that question. The setup for our demonstration is simple. I have a golf ball that I'll heat with some hot water, and I have two cameras, a cooled A8300 SC camera and an uncooled T1 KSC camera. I'm going to drop the golf ball and track its temperature over time. This is FLIR Research IR software displaying the thermal movie results and corresponding time versus temperature plots. The cooled A8300 SC camera results are displayed on the left, and the uncooled T1 KSC images are displayed on the right. Performing a qualitative analysis, we see the ball image taken with the uncooled camera, showing a comet tail or thermal smear behind the golf ball. The comet tail or smear is not reality and the result of a slow responding uncooled sensor. In contrast, the ball image captured with the cooled camera is much cleaner. This is the result of a faster integration time or exposure time with no thermal smearing. This is reality. The quantitative analysis is displayed in the time versus temperature plots. These graphs are plots of the maximum temperature from the camera field of view over time. The cooled camera plot on the left shows a relatively steady maximum temperature with only a 1 degree delta measurement. This is reality. Conversely, the uncooled camera plot on the right shows considerable variance in the maximum temperature with a 7 degree delta measurement. This result suggests the golf ball is cooling down and reheating. This is not reality. So what did we learn from our demonstration? We learned that cooled camera systems have fast, short integration times or capture times that allow us to stop motion on the moving targets. The uncooled camera has what is called a time constant, which is kind of like exposure time, and we learned that is much slower to respond to changes in temperature. So what does all this mean? I doubt you're going to be measuring the temperature of golf balls, but if your application requires looking at a target that is moving or is dynamic, a cooled camera system may more accurately capture the information because it reacts faster, whereas an uncooled camera system may produce motion blur. So what about targets that are static? Are there any differences between cooled and uncooled cameras? Even on targets that are static, if they are thermally dynamic, meaning they change temperature rapidly, the cooled camera system will react more quickly to those changes in temperature, whereas the uncooled camera system will be much slower. You may actually miss capturing important data. I hope you enjoyed this demonstration. If you would like to learn more about cooled and uncooled camera systems, check out some of the videos, white paper, and application notes we have available on FLIR.com. Thank you.